I've been getting some questions about linear velocity versus angular velocity. And so for a demonstration, here I have my daughter's birthday cake. It's getting a little old. This is what's left. So no worries. You know, I'm not taking away anything from her. So let's say we take a slice of cake, right? So here's a line, and let's say we take a slice this wide. All right, you can see the line there, right? Okay, so notice that I've rotated a certain number of degrees, right? This is about 4 degrees. And though I've rotated the same number of degrees, the outside of the cake is much longer than the inside of the cake. So in this part, this distance is only a couple inches. Whereas this distance is pretty much double that, maybe 2.5 times that. So let's say that we were spinning this cake. So here's my knife. We're going to see the cake spin underneath it to this point. The whole cake has the same angular velocity. However, the outside of the cake being longer, if there were a little dot like there is right here, that dot on the outside of the cake is moving faster in a line than the points on the inside of the cake. In other words, the rotational velocity or angular velocity is the same for the whole cake. But if we had a bug sitting on the outside right there, and we had another bug sitting on the inside right there, again, my daughter's done with this cake, I'm not ruining her birthday. If we had a bug sitting right here, another bug sitting right here, as the cake rotates, the one on the outside is covering a longer distance than the one on the inside. So how could we measure that? Well, for this bug, we would say it moved so many centimeters, excuse me, put that back under the cam, so many centimeters in so much time, a distance over time. That would be our linear velocity. The whole time it has a linear velocity. It's going this way, then it's going this way, then it's going this way. So it is changing direction, thus it's accelerating. But what about the whole cake? The whole cake is spinning, and so it has an angular velocity or a rotational velocity. Well, how can we measure that? That's going to be the number of degrees or the number of radians that we've turned, the number of radians per some set period of time. So that could be radians per second or degrees per second or total rotations per minute, but it is some degree or radian rotation in some set period of time. So if our bug walked from the outside to the inside of the cake as it was spinning, we would see no change in its rotational velocity because it's still rotating at the same rate, but we would see a change in its linear velocity. It now would be covering a smaller distance in the same period of time, so it would have a lower linear velocity, but yet the number of degrees per second or radians per second is still the same because we're not worried about the distance, we're worried about the angle when it comes to rotational velocity. Hopefully that's helpful. Let me know if I can help you further.